TH going for Solar Cities once again, and once again standing on this wonderful field of gaseous gold, I like to say. One man's trash is another's gold. This biogas digester is, of course, producing this incredible methane that you see me bouncing on here. One of the issues that still needs to be worked out to raise the efficiency of this process is the removal of the struvite. And you can see down here, this white crud all over here, that's struvite, which is very heavy in magnesium and calcium. And it seems to be a product of the aeration. When the slurry starts coming out and it starts flowing, then you see a lot of bubbles in there, and this causes a chemical and bacteriological process that causes the accretion of the magnesium and the calcium and the potassium and the phosphorus, and you get this hard substance. And it wouldn't be a problem if it was just caking up this area, but it does tend to clog these tubes before it goes out into the settling pond over there. So that's something to investigate, to see how to keep the tubes unclogged. One thing, of course, is that struvite is used in agriculture, so there are economic benefits to collecting the struvite if it can be made easy to do. Apart from that, other things that one notes is that the settling pond is exactly the same thing as a biodigester, it's just not covered. It has the same high-density polyethylene membrane on the bottom, so it gives you an idea of what's going on under here. It's just that here, another membrane has been heat welded to the top of it, and tubes have been put underneath, running around the length of it with holes in them to collect the gas as it's produced, and then it goes out to that flare over there. You can see it over here. It's like moonwalking. It's a lot of fun. I can see kids playing on biodigesters. I know their parents wouldn't want them to. There might be some security issues, but this summer we took my son and my daughter to bounce on something filled with air like this at a children's park. They could be starting down. That's the flare over there next to the generator, so when they're not generating electricity, if they have an overage of gas, they can flare it off because methane is 21 times more potent than carbon dioxide as a greenhouse gas. So that's what's going on here, but it's identical over here, just not covered. And of course, the German experience shows us that you get about 80% of your gas in the initial digestion, but there's still enough energy content left in the slurry that if you were to cover that, you'd get 20% more gas from there. It probably isn't worth it economically, but it was there. And that's actually used as a kind of counterweight. So as the water goes from here, it acts sort of like a lung. It expands and goes down and expands and goes down. That is sort of like the Puxin system in China, where displaced water helps to maintain the level inside the digester. From here, of course, are all the sows, which are breeding. This is where the creceria, I guess you call it, is, where the pigs are born. And that's what's flowing in here. So you see the metal silos are with the feed that's being regulated, going to each sow, and then there's plastic water tanks on top. And then, of course, water discharges their fecal material, and that excrement comes in here and creates this lovely, wonderful, clean biogas. So it's much better than, of course, letting it go into the atmosphere where it would be a greenhouse gas. It's a renewable, non-fossil fuel that is clean and green. Thanks.